All right, so let's continue our multiplication of polynomials. Got a couple special cases, specifically a squaring of a binomial. This is a binomial because there's two terms in there. And number one mistake I have students consistently make is they get super excited about the property that we learned in earlier math, where we had, say, x, y raised to the second power, and that's equal to x squared, y squared. And so we learned, oh, we just distribute exponents, just like the distributive property. And then we get all excited because we're like, oh, this is just x squared. And then they might come up with negative 25. They might come up with positive 25. Either way, it's wrong. So the answer is not that. Please, please, please do not distribute the exponent. The difference between what I wrote up top and what I have down below is that this is a product and this is a difference. You can distribute an exponent over a product. You cannot distribute an exponent over a sum or difference. The real way through this problem is to write this twice. So do not do this. It should actually be x minus 5 squared is x minus 5 times x minus 5. Because anytime we square something, we are multiplying it by itself. So you ought to write it that way, that it is the same thing being multiplied by itself. Once I do that, I like to use the FOIL method. I like to know that there is a order to my process: first, outer, inner, last. It's just double distribution is the other name for it, where I take the firsts, which is the x times the x, those are the firsts, and I multiply them together. X times x is x squared. And then I multiply the outers. That's the x times the 5, the negative 5. And that's going to give me negative 5x. And then I have this negative 5 on the inside gets multiplied by this x that's on the inside. Those are called the inners. So negative 5x again. And then I finish with negative 5 times negative 5, which will give me a positive 25 to complete my FOIL process, my double distribution, if you will. And then I just combine my like terms, and that gives me a x squared minus 10x plus 25 as the correct solution to this problem. Now, if we got really good, we could actually recognize that there's a pattern here that always works. It's called a perfect square trinomial. Anytime you square a binomial, it will always work out this way. This is a plus or minus b squared. It'll always work out to be a squared plus or minus whatever the sign is, 2ab, and then plus b squared. And so what would happen is I just take the first term and square it, x squared. I multiply these together and double it. That'll get me, in this case, negative double x times 5. So doubled x times 5 would be negative 10x, because twice x times negative 5 will give me that. And then plus the last term squared. 5 squared is 25. So that's what I usually do in my mind quickly, is just to run through that pattern. It's just first term squared, multiply them together, double it, and then the last term squared. Or come off to the side, write it twice, and double distribute or FOIL. Lots of ways through this process. Now, if I utilize my perfect square trinomial formula that I was just talking about a moment ago, life gets a lot better. I don't have to write this thing out and double distribute. I can just take the pattern, which is first term squared, so 3x cubed squared, plus, so same sign, 2 times the first term, 3x to the third, times the last term, y to the 4, and then plus the last term, y to the 4, squared. If you write it twice and double distribute, you'll get exactly this result. And I want to simplify this result to get the answer that I would put in the box there. I need to square 3x to the third, which would be 9. So 3 squared is 9. X to the third squared any power raised to a power you multiply, so that's x to the 6 plus, and now there's a little bit of work here, 2 times 3 is 6, and this is x to the 3rd, y to the 4th. The work just got simple. There's nothing you can do with it, so you just write them next to each other. And then plus y to the 4th to the 2nd power. So you raise a power to a power you multiply, so that's y to the 8th power. Like that. So the longer way would have been to write it twice and then double distribute or FOIL. Let's make use of our formula if we got one. So same binomial squared setup here. The difference is this time I have a minus sign. So if you just roll through the pattern, it's first term squared, 4x to the 5th squared. The minus sign shows up right here. It's going to be minus twice the 2 terms. So that's 4x to the 5th times y squared plus the last term, y to the 4, or y to the 2nd squared. And then we just work that out to get our final simplified result. 4 squared is 16. X to the 5th squared would be x to the 10. This will be negative 2 times 4, which is 8. X to the 5, y to the 2nd, plus y squared squared is y to the 4th. So that will be one of each type where we had an addition and a subtraction of a binomial squared. Using my perfect square trinomial formula, or the pattern of first term squared, and then whatever the sign is, double the product of the 2 terms plus the last term squared.